This video gives some properties of the cross product. Please pause the video and take a moment to think about these 6 properties. Which of these are true and which of these are false? Remember that true means it always has to be true, and false means it sometimes or always false. If you think that the property is true, try to give a proof or argument for why. And if you think it's false, try to come up with a counterexample. That is, an example that breaks the statement. The first statement is false. By definition, A cross B is a vector whose direction is given by the right-hand rule. The second statement is true. One way to see this is that the length of A cross A is given by the formula the length of A times the length of A times sine of theta, where theta is the angle between A and A. In other words, theta is the angle 0. Well, sine of 0 is 0, and therefore A cross A has length 0, which means that A cross A must be the 0 vector. The third statement is false. It's true that if A cross B is the 0 vector, then A is parallel to B. That's because the length of A cross B will be 0, which means that the length of A times the length of B times sine of theta is 0. For non-zero vectors A and B, that means that sine of theta is 0, so theta must be either 0 or 180 degrees, and the 2 vectors are parallel. But the 2 vectors don't have to be exactly equal. For example, we might have A to be I, the unit vector in the x direction, and B could be 3i. And when we take the cross product, we can work out that we still get the 0 vector. The fourth statement is true. We know that I cross J is a vector of length 1. That's because the length of I cross J is given by the length of I times the length of J times sine of the angle between them, which is 90 degrees. In other words, 1 times 1 times 1, or 1. We also know that the direction of I cross J is perpendicular to both I and J, and in a direction given by the right-hand rule, well, that has to be exactly in the k direction. So we have a unit vector in the k direction. This must be k. The fifth statement is false. A cross B is not equal to B cross A. It's the negative of B cross A. One way to see this is that the length of A cross B and B cross A is the same, since both are given by the magnitude of A times the magnitude of B times sine of the angle between them. But the direction of A cross B and B cross A is opposite, because when we apply the right-hand rule to A cross B, our thumb goes one direction, and if we do B first and then A with the right-hand rule, our thumb points exactly the opposite direction. This last property might be the trickiest to think about. It turns out this is also false. Here's a counterexample. Let's let the vector A be I, B be I also, and C be K. Then A cross B, quantity crossed with C, is going to be I crossed with K. Well, that's just going to be the 0 vector crossed with K, which is the 0 vector. On the other hand, if we do A cross quantity B cross C, that's going to be I cross quantity I cross K. If we think about the fact that I cross K is a unit vector and use the right-hand rule to find its direction, we see that I cross K is going to be negative J. So this is going to be I cross negative J, which is the same thing as minus K. So these two vectors minus k versus 0 are not equal. And so this is a counterexample to this property. So notice that this property is like an associative property. So this says that the cross product is not associative. Kind of a shocking fact. Here are some properties of cross product that are all true. First, U cross V is the negative of V cross U. We already saw this. You could think of this as an anti-commutative property. Commutative would mean that U cross V is the same as V cross U, but here it's the opposite. This next property says that when you have a scalar multiple of U, a scalar multiple of V, you can pull out those scalars and put them on the front. You can think of this as something like an associative property for scalars. Remember that the cross product just for 3 vectors is not associative, as we saw before. These last 2 properties are distributive properties. When we have U crossed with V plus W, we can distribute the U and get U cross V plus U cross W. Similarly, if you have U plus V crossed with a vector W, we can distribute the W, U cross W plus V cross W. Let's use these properties to find a unit vector orthogonal to both I plus j and I plus k. We know that if we take the vector I plus j and cross it with I plus k, that will be orthogonal or perpendicular to both I plus j and I plus k. We could work out this cross product in components, but if instead we use the distributive properties, this is the same thing as I plus j cross I plus j cross k. Now if we distribute again, that's the same thing as I cross I plus j cross I plus I cross k plus j cross k. We've basically FOILed out this cross product. Now we know that I cross I is just the 0 vector, since I is parallel to itself. J cross I, that's the negative of I cross j, so that's going to give us negative k. I cross j is k. I cross k, thinking about the right-hand rule, is going to give us negative j, and j cross k is going to give us I. So our vector that's going to be perpendicular to both of our given vectors is going to be I minus j minus k. In other words, 1, negative 1, negative 1. To make this a unit vector, we can just divide by its length, square root of 3. And here's an answer, a unit vector orthogonal to both of these vectors. Of course, the negative of this vector would also work. This video gave some properties of cross product that always hold, including distributive properties and the anti-commutative property. It also gave some examples of properties that didn't always hold. In particular, the associative property doesn't always hold for cross product.